and the Ministry of
Hello viewers, welcome to another lesson in mathematics at the senior secondary school level. As we have in our previous lesson, we had an assignment, so we just need to correct that assignment. ABCD is a rectangle in which AB is equal to 2.8 centimeter and AD is equal to 3.3 centimeter. E is a point on DC. Produce such that triangle AED and rectangle ABCD are equal in area. Calculate DE and AE. Let us get our rectangle first. The sketch is always very important. The rectangle first. rectangle A, B, C, D. They tell us AB is 2.8 centimeter, AB 2.8, and AD 3.3. This is AD 3.3. E is a point on DC. E is a point on DC. We should have a point on DC here. That point will be E. Produced such that triangle AED, we have to get a point on DC first. Produce such that triangle AED. We have A here, you'll have E here, then you have D. It's something like this, somewhere around here or anywhere. So this is going to give us our E. It's a point on DC. What else? So that they tell you triangle, so that triangle AED and rectangle ABCD are equal in area. Calculate DE and AE. DE and AE. How do we get this? First, DE, we have this as 90 degrees, is a right angle triangle. This one here, you can find the area of the rectangle. Area of rectangle is length times breadth. Area of rectangle is length times the breadth. The length of the rectangle is 2.8 centimeter times 3.3 centimeter. 0.24, 9.24 square centimeter. 9.24 square centimeter. 9.24 square centimeter. This is the area of the rectangle. They tell you the area of the rectangle and the area of the triangle ADE are equal. Area of triangle is equals to half base times height. If you get the diagram a little back from our triangle, this is the height and this is the base. The base of the triangle is DE. That is one of the things that we are asked to find. So the height is 3.3 and the area is 9.24 because you are told it is equal in area with the rectangle. So that will give us 9.24 is equals to half base, that is DE, times the height, that is 3.3. Half base DE times the height, that is 3.3. What can you do? You can divide both sides throughout by 3.3. Dividing 3.3, divide throughout by 3.3, and here also you divide by 3.3. How much do you have? 9.24 divided by 3.3, that will give you 2.8 is equals to half DE. Now you have half DE and 2.8. If you want to get DE, you have to multiply both sides by 2. So you multiply this one by 2 and multiply here by 2. So this is going to give us 5.6. 5.6 is equals to DE. 5.6 is equals to DE. That will be in centimeter, 5.6 centimeter. That is DE. So that is one of them. The next one, this is the next assignment. Find the dimension of the triangle ABC below. You will find the sides of the triangle, meaning you have to find AB, you find BC, and you find AC to get the dimension of the triangle. How do you do that? You apply the Pythagoras theorem. What did the Pythagoras theorem tell you? It tells you C square is equals to A square plus B square. C square is the hypotenuse, that is 2A whole square, is equals to A square, that is A minus 3 whole square. Then you have plus 11 plus A whole square. We expand this. If you expand this, this is 4A square is equals to minus 3 whole square. That is A minus 3 times A minus 3. Then this will give us A minus 3, A minus 3 plus 11 plus A whole square. That will also give us 11 plus A and 11 plus A. So you expand this. If you expand, you will have 4A square is equals to A times A, that is A square, minus 3 times A is minus 3A, A times minus 3 is minus 3A, minus 3 times minus 3 is plus 9. You expand this, plus 11 times 11 is 121 plus 11A, because 11 times A is 11A, then you have 11 times A is 11A, then you plus A square. What do you do next? You collect like terms. This is A square at the far end here. You will have 4A square minus A square minus A square is equals to minus 3A is minus 6A, minus 6A plus 11A, that is 5A, and 5A plus 11A is 16A. Yeah? This is going to give you 16A, then 9 plus 121, that is 130. 9 plus 121, that is 130. This, if you look at it, it's an equation in which the variables have the highest power of the variable is 2. So it's a quadratic equation. So 4A square minus A square minus A square, that is 2A square. 2A square is equals to 16A plus 130. Writing this in standard form is 2A square minus 16A plus 130 is equals to 0. Sorry, the 130 should be minus instead, because you are transposing it. Minus 130 is equals to 0. We can reduce the equation dividing throughout by 2. We divide here by 2, we divide here by 2, we divide here by 2. Then divide the 0 also by 2. 2A divided by 2 is A square minus 16 divided by 2, that is 8A, minus 130 divided by 2 is 65. So you have 65 is equals to 0. Factorize, or you use completing the square method or the formula method to find your A. If you are to factorize, look for two numbers. If you multiply them, they'll give you negative 65. And if you add these two numbers, you will have negative 8. That is negative 13 and positive 5. That is negative 13 and positive 5. So you will have a square minus 13a plus 5a minus 65 is equals to 0. We group them and factorize by grouping. What is common is a. So you will have a outside, you have a minus 13. Then here is 5, the common factor, 5. Then you have a minus 13 is equals to 0. So you will have a plus 5 and a minus 13 is equals to 0. If you use the zero product, you will have a plus 5 is equals to 0, or a minus 13, or a minus 13 is equals to 0. A minus 13 is equals to 0. So your a is equals to minus 5 or 13. Hence, you are looking for distance. Your right answer is going to be positive 13. It cannot be negative. So therefore, the value of a is equals to 13. We find the dimension of the triangle. The dimension of the triangle is AB, comma, AC and BC. So AB is what? What is the distance on the triangle of AB? If you look at the triangle, AB is a minus 3, AC is 2a, and BC is 11 plus a. AB is a minus 3, BC is 2a, that is a minus 3, a is 13, 13 minus 3 is equals to 10 centimeters. Then AC, this is AB, then you have AC, AC is 2a. AC is 2a, so you have 2 in bracket 13, which will give you 26 centimeter. Then the last one is BC. BC is 11 plus a. So it's going to be 11 plus 13. And that will give us 24 centimeter. This is end of the assignment correction. Now we go to the topic proper. Now we move on to the lesson proper. The lesson is trigonometric ratios. Trigonometric ratios is the lesson. So fundamental trig ratios are sine, which is abbreviated as SIN, pronouns sine, SIGN. Then the other one is cosine, is also abbreviated as cos, COS, but pronounced as cosine. Tangent is the third one, abbreviated as TAN, tang, but can also be pronounced as tangent. Greek letters like theta and beta are often used to represent angles. Of course, we can use other letters. We can use the English alphabets. We can use the Greek alphabets as they use them. So all these letters can be used to represent angles. And of course, other symbols. So this, now the sine of angle and the cosine of angle and the tangents of angle, that is what we will use to find. How do we find the cosine of angle, the tangent of angle, and the sine of an angle? When the angle is theta, if you have sine theta, when the angle is theta, if you have sine theta, is written sine theta, this means the sine of the angle theta. the sine of the angle theta. If it is cos theta, the angle is still theta. This means the cos of the angle theta. Remember, theta is just a symbol and it can represent any angle. If it is tan theta, it also means the tangent of the angle theta. If it is tan theta. So let's look at what will happen. Trigonometric ratios. Trigonometric ratios. In order to name the trig ratios, you need a reference of an angle. Here the reference angle is theta. Now in a right angle triangle, we have the longest side of the right angle triangle, which is called the hypotenuse. And the other two sides of the right angle triangle is differentiated by where your angle of concentration is. If you are concentrating on theta, the side opposite the angle theta is labeled as the opposite, and the other side adjacent the angle theta is labeled as the adjacent. If you just label your theta, where you put your theta at one side of the triangle apart from the right angle, the side opposite that theta is the opposite, and the third side becomes the adjacent of the angle. Now that is what is explained. If the angle reference, then the leg of the opposite is called the opposite, the leg opposite the theta. That is just the side opposite the theta. The other side becomes the adjacent. Now let's consider this diagram. We have another right angle triangle. This is a right angle triangle. This is the right angle. We will change the position of the theta. This is the position of our theta now. We want to label the other sides. Of course, the longest side is the hypotenuse always. The longest side of the right angle triangle is the hypotenuse. Now the other two sides is determined by the position of your angle, that is theta. Now theta is here. The side that is directly opposite theta is called the opposite, that is this side of the right angle triangle. This is the opposite, and the other side becomes the adjacent of the theta. The side adjacent theta is the adjacent. So these are the three sides you can have on a right angle triangle. We have the hypotenuse, then we have theta, where we have theta, our angle of concentration. The side of the triangle that is directly opposite that angle of concentration, which is theta in this case, is the opposite, and the third side becomes the adjacent. That is just what is explained. As we switch the position of theta, the side directly opposite the theta is the opposite, and the other side that is adjacent the theta is called the adjacent, and the longest side of the right angle triangle is the hypotenuse. Now trig ratios, they have special ratios. They are linked. If you look at them, you have the angle of concentration, that is very important, and also you have the hypotenuse. Your angle of concentration tells you the other two sides, which side is the opposite and which one of them is the adjacent. Now in this right angle triangle, we have our theta here. After drawing the right angle triangle, we have theta on top. Now we have the other sides of the right angle triangle. First, the longest side of any right angle triangle is the hypotenuse. Then the other two sides depends on the angle of concentration, which is the side that is directly opposite theta is the opposite, and the other side is the adjacent. Of this, you look at this, the labeling. You have sine theta is equals to opposite over hypotenuse. If you have this, the hypotenuse is here, that is the longest side of the right angle triangle. I am labeling it as C. and the opposite I am labeling it A, and this one I am labeling it B. So the hypotenuse, whatever value is on the hypotenuse, is what you will have to put at this end here. Then you look at them, the abbreviation of this hypotenuse is abbreviated as HYP, and opposite is abbreviated as OPP. So sine theta is opposite over hypotenuse. Cos theta is adjacent all over hypotenuse. That is the other side of the right angle triangle. That is the adjacent side all over the hypotenuse. Then the other one, the last one, is the tan theta. Tan theta is the opposite side all over the adjacent side. Opposite side over the adjacent side. As I tell you, opposite is abbreviated OPP and the adjacent is ADJ. Now, in a way that you can quickly remember this, trig ratios, this you use the SOHCAHTOA. SOHCAHTOA will help you to remember these trig ratios. This is the first one. SOH is the first one. S stands for sine, and O is opposite, H is hypotenuse. C is cos, A is adjacent. So we have all the three ratios. Then the other one is T. T there is tan. Now, if you have SOH, meaning S is sine, sine is opposite, S is sine, which will give you opposite over, the opposite is O, then the H is hypotenuse, opposite over hypotenuse. The other one is CAH, that is the second set of three letters. The C is the cos, and A is adjacent, and H is hypotenuse. So you will also have cos theta is equals to adjacent over hypotenuse. In the acronym CAH, the second set of the three letters. Now the third one is TOA, TOA. The first letter there at that set of three letters is T, and that one is tangent. And the second letter is O. O is opposite and A is adjacent. So this means tan theta is equals to opposite over adjacent. Tan theta will give opposite over adjacent, like the way they are there. So these are the three basic trig ratios. Then we move on. Okay, we have a correction here. What is the ratio of sine theta, cos theta, and tan theta? What is the ratio of sine theta, cos theta, and tan theta? Now, in order for us to do this, we have to remember the previous slides. What do we learn from the previous slides? We learn the ratios of sine. We know sine theta is equals to opposite over hypotenuse, and we know cos theta is equals to adjacent over hypotenuse. Tan theta will be equals to opposite over adjacent. And the sides of the right angle triangle, we know the longest side of the right angle triangle is the hypotenuse, and the side opposite the angle theta is the opposite, and the one adjacent theta is the adjacent. So we have to identify those things in the right angle triangle. First, we have our theta on the right angle triangle at this side here. Then the one that is the side directly opposite theta is the opposite, that is this side here, and that is 14. The adjacent side is 7, and the hypotenuse is 16. So we are asked to find sine theta, cos theta, sine theta, cos theta, and tan theta. So we can also use the acronym SOHCAHTOA, SOH, CAH, and TOA. So what is sine theta? If you come to the SOHCAHTOA, is the first set of 3 letters. S is sine. O is opposite. We go to the right angle triangle. Which one is the opposite? The opposite is 14 because it's the side that is directly opposite the angle theta. So there we will have 14 all over. The other side, O is the opposite and H is the hypotenuse. So which one is the hypotenuse on the right angle triangle? We said the longest side is the hypotenuse, which is 16. So sine theta will be 14 over 16. The next one is cos theta. Cos theta is the second set of 3 letters, CAH, cos theta, CAH. Now, C is cos, A is adjacent, and H is hypotenuse. So cos theta, this means cos theta is equals to adjacent over hypotenuse. What is the adjacent on the right angle triangle? The adjacent is 7. So we have our adjacent 7 all over. What is the what is the hypotenuse? The other letter is H, and that is the hypotenuse. What is the hypotenuse? Is the longest side of the right angle triangle. That one is 16. So we go to the last one. That one is the last set of 3 letters. That is TOA. T is tan, O is opposite, and A is adjacent. So what is the opposite of the right angle triangle? The opposite of the right angle triangle is 14 because it's the side directly opposite theta. So that is 14 all over the adjacent. The adjacent of the right angle triangle is 7. So tan theta will be 14 over 7. This is the way we solve questions like this. We are asked to find the ratio of sine theta, cos theta, and tan theta. So these are the ratios of sine theta, cos theta, and tan theta with respect to the trig ratios we learn. Reciprocals of the trig functions. Reciprocals of the trigonometric function. Now let's look at the reciprocals of the trig functions. First we have the...
Can you repeat where you said, let's move on to the first question, to the next question. Can you say next?
All right.
Instead of mentioning question. Yes.
So let's move to the next slide. The next slide is reciprocals. Now reciprocals, we have reciprocals. Reciprocals, we look for sine theta. What is the reciprocal of sine theta? This will be the same as 1 over sine theta. That is the reciprocal for sine theta. Now you know previously that sine theta, if you follow the SOHCAHTOA, we know sine theta is the same as opposite over hypotenuse. So this will give us 1 over opposite over hypotenuse as our reciprocal. Now this is the same as 1 divided by opposite over hypotenuse. So we change division to multiplication and inverse the fraction. This will be 1 times hypotenuse over opposite. So the reciprocal will be hypotenuse all over the opposite. And this reciprocal has a name. The reciprocal of sine has a name, and the name is cosec. Cosecant. That's the full name. The short form is cosec. So we write it, then this will be cosec theta. So where you have the reciprocal of sine theta, that will be cosec theta, and cosec theta is the same as 1 over sine theta, which is the same as hypotenuse over opposite. Cosec theta is the same as 1 over sine theta, which is equals to hypotenuse over opposite. That is the reciprocal of sine. Now the reciprocal of cos. Cos theta. When we say reciprocal of cos will be 1 over cos theta, which is the same as, what is the formula for cos? If you follow the acronym, is CAH, the second set of 3 letters. That is going to be 1 over, A is what? Adjacent, over hypotenuse. Then this will be the same as 1 divided by adjacent over hypotenuse. So you change division to multiplication. This will be 1 times. If you change division to multiplication, this will give you 1 times hypotenuse over adjacent. You have to switch it, inverse the fraction if you change the division to multiplication. And 1 times hypotenuse over adjacent, that will give you hypotenuse over the adjacent. And this also has a name, the reciprocal of cos. It has a name called secant. And the short form of writing secant is sec. So this will be sec theta is equals to hypotenuse over adjacent. Hypotenuse over adjacent. So this is the same as 1 over cos theta. Sec theta is equals to hypotenuse over adjacent. That is the reciprocal of cos, and which is the same as 1 over cos theta. So we look at the third reciprocal, that is tan. The third reciprocal is tangent. So we look at tan theta. Tan theta, we know tan is the last set of 3 letters, that is 2. So the reciprocal tan theta is opposite over adjacent. Opposite over adjacent. Now the reciprocal of tan is 1 over tan theta, which is the same as 1 divided by opposite over 1. Let's 1 minute. All right. Opposite over adjacent. So this will give us 1 divided by opposite over adjacent. Now we change the division to multiplication. This will be equals to 1 times adjacent over opposite. So 1 times adjacent over opposite is adjacent over opposite. 1 times any number is that number, or any number times 1 is still that number. So this will give us adjacent over opposite. So this is the reciprocal of tan, and the name for the reciprocal of tan is cotangent. Cotangent. So the short form of writing cotangent is cot. So cot theta is equals to adjacent over opposite, which is the same as 1 over tan theta as reciprocal. So these are the 3 reciprocals. The reciprocals of sine is cosec, the reciprocal of cos is sec, and the reciprocal of tan is cotangent. So we have them here. That is what you have on this slide. Reciprocal of sine, 1 over sine, is the same as cosec theta. Cosec theta is equal to 1 over sine theta, which is equals to hypotenuse over opposite when you reciprocate it. 1 over sine theta, that is what was demonstrated before. Then sec theta is the reciprocal of cos. That is 1 over cos theta, which the reciprocal will be hypotenuse over adjacent. And the other one is cot theta. Cot theta is 1 over tan. If you reciprocate tan theta, you have adjacent over opposite. The third side of the right angle triangle. If you are giving a right angle triangle, two sides are giving, you are asked to find the third side, you use the Pythagoras theorem. And the Pythagoras theorem says the square of the hypotenuse is equal to the sum of the squares of the other two sides. And our hypotenuse on this diagram is C. So that will give us C square is equal to the opposite, that is 3 square plus 4 square. That is the Pythagoras theorem. Now we will find 3 square and 4 square. So we will have C square is equal to 3 square means 3 times 3. So 3 times 3 will give you 9 plus 4 square is 4 times 4, and 4 times 4 is 16. So we will continue. We said C square is equal to 9 plus 16. 9 plus 16 is 25. So to find C, we square root both sides. We take the square root of C square and the square root of 25. The square root of C square is C, and the square root of 25 is 5. So we have our C as 5. That is the hypotenuse. We have 5 on the hypotenuse. We have 3 on the adjacent, and we have 4 on the opposite, the one that is directly opposite the theta. Now, how do we find these 6 trig functions? We should find sine, we should find tan, we should find cos, then we should find their reciprocals again. That is what makes it 6. That is cosec, sec, and cot. So that is what makes it 6. So we find that, if we find that, this is what we will have. So we find the missing side. The missing side C is equal to 5. Now we find the 6 trig ratios. The 6 trig ratios are sine, cosine, tangent, cosec, sec, and cot. We use the acronym SOHCAHTOA. Sine. Sine is opposite over hypotenuse. We have sine theta is equal to opposite over hypotenuse. The opposite in this right angle triangle here is 4. This is the opposite. And the adjacent is 3. This is the adjacent. And this one is the hypotenuse. So if you set opposite over hypotenuse, sine theta from the right angle triangle is equals to 4 over 5. Cos theta is adjacent over hypotenuse. The adjacent is 3 and the hypotenuse is 5. So cos theta is equals to 3 over 5. And the other one is tan theta. Tan theta is opposite over adjacent. The opposite is 4 and the adjacent is 3. So tan theta is 4 over 3. Now the reciprocals. The reciprocal of sine is cosec. you just take the reciprocal part of it. If it is 4 over 5, if you reciprocate 4 over 5, you have cosec. Now, cosec, we reciprocate 4 over 5, or we use the reciprocal formula, that is hypotenuse over opposite, is still the same. That will give you 5 over 4. And the same as you reciprocate 4 over 5. Then we go to the other one, cos theta. The reciprocal of cos theta is sec theta. What is the reciprocal? The reciprocal of 3 over 5 is 5 over 3. That is why we have sec theta. It's easy when you have the first one and you are just asked to find the reciprocal. Now we go to the last one. Tan theta is 4 over 3 and cot theta is the reciprocal of tan, that is 3 over 4. So this is what we have. These are the 6 trig ratios we are asked to find, trig functions we are asked to find from the diagram we have. So this brings us to the end of the lesson. Until we come again, thank you for your kind attention.
COVID-19. Leave no one behind. Coronaviruses are a large family of viruses that cause illness, ranging from the common cold to more severe lung diseases. COVID-19 is the most recently discovered disease caused by coronavirus. As we fight this pandemic, we must be kind by supporting others. COVID-19 is not specific to any sex, gender, race, nationality, or skin color. So, let us not stigmatize or discriminate against anyone or certain groups. Fear of exclusion and discrimination may result in those who may have contracted COVID-19, including migrants, to hide their symptoms rather than seek treatment. This puts everyone at risk of getting sick. In many contexts, people who migrate to work, study, or join their families are key players in nation building, including combating COVID-19. Let us all play our role in challenging misinformation and discrimination against migrants. Be considerate of others' needs and do what you can to help. Encourage others to wash their hands frequently. Avoid touching their face, eyes, mouth, and nose. Practice proper cough etiquette. Avoid public places. Practice social distancing and stay at home if they feel unwell. The Gambia is called the Smiling Coast because its people are kind. Let's show that kindness in fighting COVID-19, our common enemy. Let's fight it together. For more information, or if you experience any symptoms, dial 1025. COVID-19.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel, Yai Baram.
I get it. Albaka.
Mbaka important.
Yo, nga transfer la story.
Ya transfer la story.
Ha, code nyingi.
Okay. What's that?
Nsila ID soto.
Ah, that's what. Sorry. I get it.
Bijan bro.
Albaka.
Mbaka.
Bara Allah service o tariaka.
Mbale.
Mo ki janna nun kono bara tariaka.
Jannom yona forest de bureau. Gambia tonkon na no mbali ya bere. Birin koyna fo kato.
Bari si kodo kino kato nim fo bolong blabe ko.
56 branches mola sota Gambia jang.
Ha?
Gambia kono ani Gambia bantala bankol. Nko kono ki ya bere. Kodo sifa fo falindiro fo nyaadi lafta même na kodi to poto nin kodi maraw jannam number 1 ti nyonta andum fana nata anoda enterprise sotale wolam nyindi ko domorol fana kol fana be firale le dadi man domorol dil fana beteat Gambia dawda yalo ngam fa kendol sotale je
wo moyo diat
apelenta
baraka ba ni lafta nyelen kendol e bina
yalo bu kanila ko la baraka ba
yalo ndel ciosano lo
baraka.
When we touch down, bed I broke down.
Gamtel G-Fiber, now you can enjoy super fast internet in gigabytes. G-Fiber is affordable, stable, secured, and accessible to homes, businesses, and enterprises. With Gamtel G-Fiber, the future is speed. Gamtel, creating a brighter future in communication.
That's how she became mine and see that.
domoro kadiyate
boy jannon sikes restaurant
e say nakko be ninna dimbal nimba domoro kala janno
domoro seneyata adiyata topotoro fanan kendema bije luntan during tamala abeka domoro ki janni adi manda wala de te ka we bijele anim fanan ka fadi jang ikono e fa e ka fa minne ko pastry anim bakery iko fanan be kalele badde lomba conference lomba workshop lomba ye fo fendin lon dunia kono domoro betama nyillom international otoda number 1
amanke ba domo la jandama
e sa domo jang is atariya
wo mu kubandi
sa nakko sa futandin
e oto sa nakko be mu sikes restaurant
ndafa na janna mu yat ni manje dorom bija
aban
CK's Restaurant, known for best quality food and customer satisfaction.